Research Basics video, we're going to continue talking about descriptive statistics. This is part 2. If you haven't watched part 1 yet, please go back and do so. This video covers understanding variability. In the simplest of terms, variability reflects how much scores are different from one another. For example, let's take a look at the following sets of scores. There's our first set. Here's our second. And our third. Let's go ahead and compute the mean for each set of these scores. Why? Because the mean and variability, sometimes called spread or dispersion, gives us the best picture of what our data look like overall. The mean. Again, this is something we covered in part 1. If you haven't watched part 1, please go back and do so. To compute the mean, we'll go ahead and use this equation, x bar equals sum of all x, divided by n. We start by adding all of our values, that's the sum of all x, and dividing by the number of values in the set. So for each, we have 20 divided by 5, meaning our mean is 4. And the mean is 4 for both of the first and second set of scores. Interestingly, the mean is also 4 in our third set of scores. Now, it's a little bit difficult to tell, other than here, how much the data vary with each set of scores. We know with this all fours set that it doesn't vary at all. There'd be no reason to do much analysis if all of our data is the same. But let's try to figure out how much our data vary in the first and the second set. First things we can do to discuss how much our data vary is to take a look at the range. Now, the range is a pretty simple statistic to calculate. Our range equals the highest score in our data set minus the lowest score. So for these first set of data, the range is equal to the highest score, 7, minus the lowest score, 1. And so the range for that first set of scores is 6. Let's take a look at the second set. The range is equal to the highest score minus the lowest score, and so our range is 2. The more, or the higher, the greater the number in our range, the more variability in the data. So in this case, this very first set of numbers, 7, 6, 3, 3, 1, the range is 6. We would say the range of these data has a maximum value of 7 and a minimum value of 1 with a mean of 4. The next way to talk about variability is to talk about the standard deviation. Now, let's think about what these words mean. The standard deviation, sometimes abbreviated SD, is telling us that there's some kind of average or standard amount that each point of data varies from another point. So what's the logic behind computing the standard deviation? Well, your initial thought may be to compute the mean of a set of scores and then subtract each individual score from the mean. Then compute the average of that distance. That's a good idea. You'll end up with the average distance of each score from the mean, but it won't work. So here's the formula for computing the standard deviation. This lowercase s is the standard deviation. Then we'll have the Greek sigma, sum of all, x minus x bar squared divided by n minus 1, and we will be taking the square root of all of that. Don't forget, the x is each individual score in our data. X bar is the mean. N is the number in our sample. Okay. We have this set of data. We have 10 observations. And we have the score for each observation. Well, the first thing that we need to do is try to figure out what pieces we'll need to make fit into this equation or formula. Well, we have x, but we know we need x bar as well. So let's go ahead and calculate x bar. X bar equals sum of all x divided by n. Up all of the x values, that's our sum of all x. That equals 60. We know that n is 10. So x bar is 60 divided by 10, or 6. Awesome. I'm going to go ahead and create a second column here just to make it a little bit easier on myself. And I know that x bar for each one of these values is going to be 6. So I'll go ahead and fill in all of these 6's. Okay. Now, we need this piece right here, this x minus x bar. So let's go ahead and plug it in another column, x minus x bar. So 8 minus 6 is 2, 2, 2. 7 minus 6 is 1. Then we'll have a couple of zeros. 5 minus 6, negative 1. 4 minus 6, negative 2. And 3 minus 6 is negative 3. The next column that we'll need gives us the ability to take a look at this squared. We'll see in a moment why that might be important. So let's make one last column here, x minus x bar squared. Okay, so now I want to square everything in the blue column here. So 2 times 2, 4, 4, 4, 1, 0, 0. Now, the interesting thing is we square these to get rid of these negative numbers, because a negative 1 times a negative 1 is a positive 1. Negative 2 times a negative 2, positive 4. the top piece of our standard deviation formula, we have sum of all x minus x bar squared. So we're going to need to add all of these values up. The sum of x minus x bar squared is 28. We know our n is 10, so n minus 1 is 9. Our standard deviation will be the square root of 28 divided by 9. The result of taking the square root of 28 divided by 9 is equal to 1.76. So this means that each point of our data deviates from the mean by a value of 1.76. There's your standard deviation. Fact for you. If you want to check to see if you've computed the mean correctly, you can go ahead and sum all of these x minus x bar values, and when you do that, it should equal 0. Go ahead and show you in a little bit of a picture what the standard deviation is telling us. So let's say that I have plotted a bunch of different points in a data set into a scatter plot. That's what we call this kind of a picture here. And let's see if I can figure out, just kind of eyeballing it, this is about our average. That would be our x bar. Now, what the standard deviation is telling us is just how much the data vary point by point from the mean, or from x bar. The wider the points are from the mean, the larger the standard deviation. So in a way, just like the mean, the standard deviation is sensitive to extreme scores. When you're computing the standard deviation of a sample and you have extreme scores, note the fact that somewhere in your written report and in your interpretation of what the data mean is that there are extreme scores. Quick look at the variance. Taking a look at the variance, it should be a really nice surprise. See, if you know the standard deviation and you know how to square a number, then you automatically have the variance. So the variance is standard deviation squared equals sum of all x minus x bar squared divided by n minus 1. The standard deviation, but you didn't do that very last step. Take the square root, you'd have the variance. So think about it for a minute. Think back to the last example we did. Our standard deviation was about 1.76. So if we know the standard deviation is 1.76, then to get the variance, all we have to do is square that number. And we'll have the variance.